Being recorded. Okay, step 1, solve an equation for one variable. So this is just like we were doing yesterday with graphing to solve systems, but now I'm showing you another way algebraically using substitution. So first we want to solve an equation for one variable, just like we were doing on the bell ringer. Then step 2 would be to substitute. That's why it's called substitution. Step 3, solve the equation. Should I make sure you're writing this down? And step 4, plug back in to find the other variable. So we're trying to find that ordered pair. So if we were graphing these, it's where the graphs intersect. Well, that's what we're finding algebraically. We're finding the ordered pair where they would intersect. And then, as always, check your solution. All right, first step, solve an equation for one variable. Open up that. So you want to pick the easier equation. The goal is to get y equals x equals a equals. So the goal is to get the variable by itself. So let's look at the example it gives us. Solve using substitution. X plus y equals 5, y equals 3 plus x. So we want to get the variable by itself. Do you notice anything about one of those two equations? Do we already have a variable by itself? Yes, which one? Not both of them. Variable by itself. Which equation has the variable by itself? The y equals 3 plus x. Look at over here, it says it has to be like y equals x equals. So when it's the variable by itself, it's the variable just by itself on one side. So we can skip that and say the second equation is already solved. So you can skip that first step if there already is one for solved by itself. All right. Then the next step would be substitution. So for this, you want to put the equation solved in step 1 into the other equation. So put the equation solved in step 1 into the other equation. So if you want to color code with me, I'm going to choose one color to use for y and one color to use for x. So since y equals 3 plus x, I'm going to highlight that one because that's the one that's already solved. Then we need to use the other equation, which was x plus y equals 5. And we're going to substitute for y. So if y equals 3 plus x, I'm going to substitute 3 plus x. Now looking at our new equation, what is the only variable we have here? X. So that's a way to check your work because I'll notice a lot of students substituting it in the wrong place. If you see x and y still, you didn't do it correctly. So you should only have one, either x or y, depending on which one you solved for. All right, so that's step 2. Then step 3, solve the equation. We want to get the variable by itself. So just like we were doing on the bell ringer, how would we solve x plus 3 plus x. So we actually don't have to distribute. There's no number in front of the plus. So I just put the parentheses to show I substituted. Yeah, the combine like terms, add the same things that are the same. So what is the same? The x's. What is x plus x? 2x. Plus 3 equals 5. All right. Then remember, look at the side with the variable. We want to undo any addition or subtraction. So what's being added to the variable? The 3. So what would be the inverse? Minus 3. 2x equals, what's 5 minus 3? 2. And then what would be our last step? Divide by the coefficient 2. So remember, you're always dividing the number that's right next to the variable. So it's 2x, so we want to divide by 2. X equals 1. All right, we're halfway there. Remember, we need to find the ordered pair. So we know x equals 1. Step 4, plug back in to find the other variable. So open up step 4. This one, we want to substitute the value of the variable into the equation. So substitute the value of the variable into the equation. And it doesn't matter which equation you choose, just go back to the original equations up here. So which of these do you think would it be easier to substitute x equals 1? Yes, agreed. So let's do y equals 3 plus x. And then if you are color coding, use a different color to show our x value is 1. Then I'm going to highlight x to show that I'm substituting it in. So then we would put y equals 3 plus 1. Substituting for x. And then what is 3 plus 1? 4. So now we have our y value. Y equals 4. And you want to use your other color for y. So now we have our solution. It's an ordered pair. Question? When I'm done with the notes. So what would the ordered pair be for this one? 1, 4. So now we have to check that. So here, let's write solution is 1, 4. And then our steps for this is we would substitute your ordered pair into both equations. So substitute. So it's just like we were doing yesterday after we graphed it, we always went back and checked it. Same here. Your ordered into both equations. So I'm going to rewrite both original equations. We had x plus y equals 5. And we had y equals 3 plus x. And then whatever color you're using for x, if you want to highlight your x's. And then your y, different color. So now we're plugging in or substituting the values from the ordered pair into those original equations to see if they're true. So our x value is 1 plus y is 4. Does 1 plus 4 equal 5? Yes. So that one checks out. 5 equals 5. And then the other equation, 4 is our y value. So 4 equals 3 plus 1. Is that a true statement? Yes. 4 does equal 4. Checks out. And then we're going to do 2 more examples in the notebook because you'll see different types of problems. So I want to go over a couple different ones that you will see today in Delta Math. Wherever you glue it in, go ahead and glue the back where it says glue here. And then put it in your notebook. Or I have paper up here, 3-hole punch. Do you want me to open it again?
Yeah, I got a hard one.
All right, let me glue it and I will do that for you. All right, for those who still need to finish it, here it is.